Hello everyone. My name is Siablela Kyaliti. Otherwise, where I study, my English name is Paul. And so I was born and raised in South Africa. I'm 18 years old, but now I'm currently an international student in the United States of America, and I'll be talking to you about the binomial theorem, mainly some patterns and tricks which can be used with the binomial theorem. So first of all, the binomial theorem can be used with Pascal's triangle, and this is actually a final product of Pascal's triangle when it has been built, and this just indicates how you can actually build Pascal's triangle. You add up all these numbers to get the numbers in the following row. So the sum of these numbers together, they'll be the next number in the following row. And so from there, like, you can add this 0 and this 1 to get this 1, you can add the 1 and the 1 to get the 2, and so on. So it just goes on like that, and that's just how you build up Pascal's triangle. And so, as I had stated, that the binomial theorem can be used with Pascal's triangle. So we can think of the binomial theorem as this statement: a plus b is to the power n, where n indicates the row number. So that is going to be for a later stage anyway. And then from there, let's simplify another expression using factoring. So if we have an expression here like 2x plus 3 all is to the power 2, we multiply this bracket by itself twice, so 2x times 2x, we get 4x squared, and then 2x times 3, we get 6x, 3 times 2x, we get 6x again, and then 3 times 3, we get 9. So we add the like terms, we end up getting 4x squared plus 12x plus 9. And another way we can do this is that we can square this 2x, we get 4x squared. We square this 3, we get this 9, and then from there, to get the middle term, we will multiply these terms together. The 2x and the 3, we get 6x, and then we double the product of these numbers, meaning we double the 6x, so we end up getting the middle term, which is going to be 12x. And so let's simplify another expression, maybe a plus b. So if we say a plus b all squared, we multiply this bracket by itself. Again, we multiply it twice. And then from there, a times a, we get a squared. A times b, we get ab. B times a, we get ab again. And then b times b, we get b squared. And so adding the like terms, we get a product of a squared plus 2ab plus b squared. And then from there, this is where Pascal's triangle then comes in. If we look at the coefficients of these terms, we'll find that a squared has a coefficient of 1, ab has a coefficient of 2, b squared has a coefficient of 1. So the coefficients of these numbers are in this order: 1, 2, 1. And so if we look at row 2 of Pascal's triangle, which is going to be this row over here, we'll see that the numbers are also in the same order: 1, 2, 1. So this then just shows that Pascal's triangle can also be used with the binomial theorem. So in my next video, I'll be expanding more on the idea of the use of the binomial theorem.